Hello everyone, this is Xianpeng Qiao from Southern University of Science and Technology in China, and it's my honor to present my research work in 2021 Employee Wellness Week. And my research title is a novel magnetic coupled resonant wireless power transfer technique used in rotary ultrasonic machining process. And here are my presentation catalog. My presentation contains the following parts. And the first is the research background. The purpose of my research is to increase the transmission distance of rotary transformer used in rotary ultrasonic machining. This is the picture on the left. This is the rotary transformer commonly used in ultrasonic machine. As we can see, the primary and the secondary sides contains the E-shaped core and the coils. Although the transmission efficiency could reach above 19%, there are small gaps, 0.1 to 1 millimeter, and the angle and the distance deviation of the X between the primary and the secondary sides is unavoidable at the high rotation speed. And the small gap will cause the collision during the process. So it's important to increase the transmission distance as shown on the right picture. And then I will introduce the rotary ultrasonic machine. As you can see, the rotary ultrasonic machining system includes 3 parts. Ultrasonic power supply provides the alternating current to the primary coils. This part is non-rotating, and the second coils receive the alternating current to the ultrasonic vibrator. This part is rotating, and the frequency of the alternating current is close to the resonant frequency of the ultrasonic vibrator. And then a higher frequency vibration will happen to hit the workpieces. So during the cutting process, there are ultrasonic vibration to each workpiece. And this method is useful to process hard and brittle materials. For example, fine ceramics and advanced composite materials. Let's look at these 4 pictures, such as Huawei Mate 30's back panel, the corner ceramic scalpel, and the aircraft components or the vehicle's components. Now let's show the advantages of the rotary ultrasonic machining. These 2 pictures are the holes processed by traditional machine and rotary ultrasonic machine. As we can see, the quality of the hole processed by rotary ultrasonic machine is better than the traditional machining. And although the addition of the ultrasonic can reduce the chip adhesion to the tool and the processing damage, cutting force, cutting heat, and tool wear. Now here are the 3 rotary transformers. Conductive slip ring is easy to use, but the brush will weak out in use, which limited the magazine rotation speed. The inductive power transfer is proposed to replace the conductive slip, but the transmission distance is not enough, and even the collision may happen during the process. So the magnetic coupled resonant wireless power transfer have a bigger transmission distance compared to inductive power transfer. So in this research, I will use the MCR-WPT used in rotary ultrasonic machining. And then these are the second part, design the magnetic coupled resonant wireless power transfer and construct a model to explore the transmission characters. Now I will introduce the ultrasonic vibrator. The ultrasonic vibrator includes the real cover, piezoelectric smacks, flag, horn, and the processing tool. This is the equivalent circuit of ultrasonic vibrator, which can cover to full JXP and RL prior. These two are the 3-dimension view of conductive and susceptance as function of frequency and the voltage. When the susceptance B equal to 0, the excitation frequency is the resonant frequency of ultrasonic vibrator. At the resonant frequency, the vibration amplitude is the biggest, which have a good processing quality. Now, as we can see, the ultrasonic, the equivalent circuit can convert to a full JXX and RL series. So you can see the second coils and full JXX can form the resonant tone. So as seen in this picture, the dotted line represents the relationship of the voltage and current phase, and the amplitude of the ultrasonic vibrator. The solid line is the ultrasonic series with secondary coils. So as the resonant frequency of second circuit, the the ultrasonic vibrator can reach the maximum amplitude, maximum vibration magnitude, instead of the resonant frequency of sonic vibrator. And then, so the frequency of the system is the resonant frequency of the second resonant frequency. In order to form the resonance in primary, the compensation capacitor will series with the primary coils Cp equal to 1 divided by omega times xx. Now, in order to represent the influence of transmission distance and the coiltance, the mutual inductance and the inductance model are contrasted. Here are the two spiral tube coils, and this is the mutual inductance of two singleton coil, and this is the inductance of singleton coil. So the mutual inductance of the primary coils and the secondary coils equal to the sum of the mutual inductance of each coil of the primary coils and the secondary coils. And then the inductance of the primary coils equal to the sum of the each inductance of the coil, and the sum of the mutual inductance of the each coil and the other coil of the primary coils. And then is the result and the discussion. And now this is the coils I made. The line is the least well. This is the experimental parameters include the ultrasonic vibrator and the wireless power transfer. And then I put the parameters into the theoretical model, and I calculate by MATLAB. Then the three-dimensional view of output power and transmission efficiency as function of distance and the frequency are made. As you can see, there are two peaks of output power when the distance is small. As the distance increases, there have only one peak of output power. And then these are the three dimensions of output power and transmission efficiency, or the function of distance and the coiltance. In order to make these curves, the following steps were made. So, as showed in the figure, as the coil turns increase, the position of the maximum output power is increased. So this is a method to increase the transmission distance. And then in order to prove my theoretic model, here are the experimental are made to prove this. And then the vibration amplitude of the ultrasonic vibrator is relative to the processing quality. So the vibration amplitude was measured by laser vibrometer, and it is also in order to verify the efficiency of the system, the amplitude frequency response curves are made. In the right figure, this is the amplitude frequency response curve of ultrasonic vibrator. As you can see, these have one peak of the vibration amplitude. And this is the rotary ultrasonic machining systems. These have two peaks of the ultrasonic amplitude. So it's similar to the results made by the simulation. And the maximum of the vibration amplitude of the ultrasonic vibrator is 0.7 micron. However, the maximum of the vibration amplitude of rotary ultrasonic machining system can reach 1 micron. So the system, the magnetic wireless power transfer is good to use, as the transmission distance 15 mm. And then is the final part, the conclusion and the future work. To sum up what I said above, there are two parts. I use the resonance to improve the transmission distance, which above the collision. And then a series model are made to explore transmission characteristics. And the next is the prospect. The resonance frequency of ultrasonic machine vibrator is changed by during the processing, so it's essential to add feedback frequency tracking for rotary ultrasonic machining systems. And then I will improve my coils and product and then push it into industry. as soon as possible. Thank you very much for your kind attention. Any questions?